All right, so if you're watching this report, it's because you've either been following LaRouchePack.com for quite some time or recently been directed to this site for this series of videos on a special report, NAWAPA 21. Now, this report includes a full-on analysis of an economic recovery plan for the United States, in-depth, tied into the history of our country since the assassination of John F. Kennedy, and a full demonstration of the need of this project in looking at the entire Southwest, and also how this plan would be integrated with a revitalization of the system of public credit. And what I want to do now today is elaborate what this plan means as far as a 20 to 30 year evolution of the economy, and paint a picture in your mind of the motion building living system that we're going to be creating with our construction industries, with our construction craft, engineering industries, and manufacturing machine tool sector of the economy. We're going to be doing a series of videos here on the website following up on the introduction to NAWAPA 21 that we did a few days ago, covering section by section of this special report. And if you've been directed here you can see this video now to get an introduction of how to organize with NAWAPA 21. What I'm going to do now is to go into section 1 of this report in some detail so you can get a sense of what I described, this motion building and path phase by phase of how the project's going to become a reality. And here in this section, we outline the project as though it's already built. And if you read this, you get a sense of, in your own mind, everyone actively working, moving, and how the system is going to look like when it's actually completed. This is called the system requirements of NAWAPA 21. Now, it has 4 phases. And all these phases are going to be interlapping in some degree, but relatively are going to be moving independently, and one has to be completed before the other is finished. Then we're going to look at what's our current capacity to accomplish these phases as our economy stands right now, followed by what kind of technologies we could implement now so that in the certain phases later of the program, they're going to be available to help us speed up the timeline of the program and the quality of the program and the quantity of things produced, which will affect the timeline of the program. Concluding with an investment analysis of the project, and that's going to tie into the first phase, which is, in the first phase, what we're looking at is general organization of this whole system. This is a continental flood control, drought control, and general water delivery, water regulation system. This is the skeleton of the whole plan. In this plan, it's going to open up whole developments in resource development and in the colonization of and settlement of new parts of the continent we haven't touched before, made accessible. This general organization of this whole system now is going to include management teams, and what they're going to be doing is they're going to be essentially setting up, as we did with something like the TVA, a grouping that's going to get the top-down overview of the whole project. And they're going to figure out as they do that somewhat of the best way, the plan, what should be done first, the order of operations. And essentially there's going to be some kind of control center, control room, in which all of the data necessary for the early phases of design, as we start to finalize what was done in 1964, what we want to update now with new additions, all of the designs, all the plans and data as far as what do we have in labor capacity right now, manufacturing capacity, because this is going to affect the timetable of construction. You have to remember the fact that from 1964 to now, 2012, the customers and the industries that were available then to move immediately are now are relatively an order of magnitude, I would say, less. So we're going to have a different time schedule and a different sense of what we're putting into motion as far as skilled workers and what the state of the manufacturing industry is. All of that data is going to have to be inputted into state-of-the-art systems in the control center of this NAWAPA 21 body of authority, like some kind of authority with representatives of the 3 nations, and will probably be situated in Idaho, as this is sort of the inflection point of the whole system, because we have a collection function, a transfer function, and distribution. And it's also right at the border. Idaho is at the border of Canada and the United States. And it's also most energy dense of the way in which the design currently is laid out of the entire system as far as energy consumption and the pumping requirements, massive manufacturing facilities there. So in Idaho, we're going to have, I'd say probably in Idaho, but in some control center of the system, we're going to be looking at all of this information and figuring out what's the best way in which the timetables, which are going to be constantly adjusting, both for design, pre-construction, phase 2, construction, phase 3, and then finally phase 4, operation. And I'll come to this at the end, where we're looking at the operation phase, how that's going to work with a special division of this control center. Now, in addition to that, we're going to have immediately set into motion, before anything even gets built or anything even gets authorized, we're going to have topographical mapping of the whole plan updated. We've done some of this ourselves, actually using software of looking at how these reservoirs are all laid out with the elevations, and essentially how this natural topographical features of the continent makes it the fact that we don't need any canals or aqueducts in the entire collection system, pretty much. Now, we're going to be doing also geotechnical surveys. We can do a full geological mapping of this whole system, which is therefore going to update our actual scientific knowledge of the continent. We're going to be figuring out all kinds of new resources, potential seal alloys in the north, because of all the new areas that are going to be opened up and mapped. In the engineering phase, just the geological mapping phase, we can get a much more in-depth picture of how this whole system could work. With new technologies, with new tunnel boring industries, we could even change the original route due to things being made accessible that weren't accessible before. So we also may be able to apply things like LiDAR, other satellite imagery that will give us a much more clear picture of what the geology and what the route should be of the program than was the case in 1964. We're going to have biologists looking at the reservoir effects. We're going to have foresters looking at the harvesting of all of the lumber as the site preparation later on in construction is going to begin. We're going to have all these kind of scientists involved in this general mapping. We're also going to have people designing out, based on that analysis, what these pump stations are going to look like, what the dams are going to look like. Civil engineers, cold weather engineers, mechanical engineers, all kinds of engineers you can think of in that. Material engineers, what kind of cement are we going to use? Are we going to use roller concrete method? Are we going to use other methods? What kinds of all the other new technologies can be put in the front? After this phase, once things get essentially set for that, we're going to be doing pre-construction phase. We're going to be phase 2, pre-construction, will include how we're going to certain land acquisition. A lot of this is going to be government land, how we acquire that, what kind of special things the authority might have as far as how it goes forward with its program to make things a bit easier for this authority. Certain things will be related to land acquisition. The boundaries of the countries, how that gets done, the boundaries of the states, access easements, things like this. Now there's a question then of gaining access to the areas, access construction. We're talking about rail, we're talking about bridges, tunnels, all the kinds of things we're going to have to do to even gain access to some of these construction sites. And also the bringing in utilities to power the area. We're going to have all kinds of high-powered machinery, linemen. We're going to be working there to bring in the power to run all of the machinery equipment at somewhat remote sites. And certain new roads are going to have to be opened up that we're going to have to get right away for that. But new highways and rail are going to probably be built, especially in the north. And this is one of the earlier phases. It could be a 5-year to 10-year construction of the Alaskan-Canadian rail system about 2,000 miles of rail. And something like that could have a wide array of other potentials, even outside of just the reservoir construction, canal construction, and things like that. We'll have to probably have some rail routes also in the Southwest, especially some rail routes in Idaho. People think we're going to have some extensions on the Burlington, Northern Santa Fe routes that we have, triple track some routes, double track some others, because we're going to be moving a lot of supplies, especially from the Midwest. This is where we still have a lot of industries. So as we gear up these industries now, we're going to have to use these new routes, new bridges and other kinds of things. So in this, we're going to have all kinds of geophysical engineers, civil engineers, iron workers, form setters, big cranes, 500-ton cranes. We're probably going to have to get some new crane manufacturing going in the United States. We're going to have to get a lot of different material construction in the United States. This is going to include material production, cement production, steel mills are going to have to be produced, foundries, all kinds of other things that we're going to be needing for rock crushing, all this material production, anywhere you're going to be pouring cement, which is going to be a lot of places with the amount of dams that we have in this project, we're going to have to set up new quarries. And the rock crushing facilities alone will be a very profitable business, in fact. But we're looking at all these arrays of material production. Then we have machinery production. All kinds of machines, as we say, cranes, excavators, tunnel machines, all these kinds of machinery are going to have to be done. Tunnels, there's going to be almost 1,200 miles of tunnels. There's 39 tunnels in the project, most of them in Idaho, Montana, and the Southwest. This is where then the topography, as we go through the Rocky Mountains, Idaho, and then into the distribution, we're looking at a lot of separate reservoirs, separated by 40 to 50 mile tunnels in some cases. We're going to have to get a lot of tunnel boring in the United States. This could be a big push. There could be a big push for R&D in the United States. The United States as a tunnel boring industry could surpass anywhere in the world with the amount of tunnels that are going to be needed in this project. That's going to be 1,200 miles of tunnels, almost 13 million cubic yards of concrete, almost 670 million cubic yards of earth moved. Pump manufacturers. This is also something right now, we don't currently have a pump manufacturer that's capable for the task. We may have to get a license from Hitachi or something until we have this capacity in the U.S. Again, with these massive pumps, this is going to be foundries. This is going to be a lot of casting, forming things. We have to revive in the United States that we currently, most of our foundry casting is done abroad. With these pumps, however, this is bigger pumps than just getting our own big pump manufacturer. These are 100,000 horsepower pumps. And there's going to be an army of these with the current design of the sawtooth lift and even some of the other big lifts in the project. We have four major pump lifts, one in northern BC, one in southern BC, into the Rocky Mountain Trench, and then the whole Idaho transfer function is a continuous pumping up. And then one out of Lake Navajo in Arizona. These pumps are going to be massive. 100,000 horsepower is currently bigger than any pump as we currently have. We're going to have almost 37 gigawatts of pumping facilities in operation. There's going to be almost 2.5 tons of steel in these pumps, almost 20 million cubic yards of concrete. And there's going to be about 14 major pump stations in which each pump station will have a lot of pumps. Then we're looking at all the other machinery involved. This is all just machinery production in canals. We're going to have a lot of excavators, obviously. We're going to have cement pouring going on. So there's going to be also a lot of that, a lot of cement. Cement equal to 130 million cubic yards of concrete, almost 70 million cubic yards of earth, and for 4,500 miles of canals. So we may have some kind of technology investment in a canal excavator based on the amount of redundancy of canal excavating that's going to be going on. We may want to have some advancement in that. Also, the supply lines. We're going to be bringing in all these areas, we want to be bringing in this massive machinery, massive construction equipment. We're going to need things that you don't see a lot in the United States, Schnabel cars. These things look like giant insects moving down the track. They have a capacity of about 150 tons. We're going to need to build a lot of these things, and heavy capacity track as well. There's currently, as designed, we've done this 95 dams in the project. That means about 200 million cubic yards of earth, 430 tons of steel, and 2,700 million cubic yards of concrete. We made the dams seismic up in the north. The original design was rock-filled dams. So what we're looking at is with all of this, the pumps, the canals, the tunnels, the power stations, the locks, the dams, the total amount that we've calculated so far, and this doesn't include some of the eastern stuff that we have not included in this design. We're looking at about 27 million cubic yards billion cubic yards of earth moved, and almost 30 billion cubic yards of concrete, and about 400 million tons of steel. Phase 3 is the construction of all of that, bringing all this material, constructing it, which is going to have site preparation, clearing, logging, all the kind of diversion tunnels, cofferdams for each dam. Obviously, all of this construction is going to have its own phase. Now, these phases are going to be intersecting. We're going to have, some years into the project, a beginning operation phase. This control center that I went through originally, the control center is going to be first getting a sense of all the pre-construction needs. How quickly can we advance the pre-construction phase, investments into plant construction and investments into training all of the different engineers involved. As I mentioned, pipe fitters, cement workers, iron workers, millwrights, switchgear workers, linemen, all the different kinds of machinists, the lathe operators, all the different kinds of engineers, professional engineers, mechanical engineers, nuclear engineers, everybody that's going to be involved in this. We're going to have to get a sense of what's the training needs and what's the plant capacity needs versus what's the capacity that we can have. So that'll be this grouping of the control center will be analyzing all of that, figuring out how that's going to work. They're also going to begin, as certain parts of the project come online, the operation phase, which is the fourth phase of the project. The operation phase, you can have in your mind an image now of all of this in motion. And you can have the beginning parts of the project come online, you can have in your motion head now the grouping that's getting a sense of this whole project. As it starts to become actualized, they're going to be monitoring the condition of every single reservoir. And what you're going to have up there is a room, a control center that has every reservoir of the system, the levels of that reservoir, and they're going to be delivering the water and maintaining the levels based on accurate analysis of every single reservoir level, based on accurate analysis of the weather. And we're going to have the most up-to-date forecast, because water that's transferred from the north to somewhere like Mexico is going to take a matter of months for the water to run down the system, but as far as being able to forecast who's going to need the water then, when. So you're going to have this whole grouping looking at and monitoring the entire system and control of delivering all of this, getting the most accurate analysis of weather, space weather, what we can make advancements in the next decade if we don't shut down our whole capacity under the current administration. We can make advancements in weather and have a accurate forecasting for this. We can also, this grouping is going to look at water treatment of the reservoirs. They're going to be studying the techniques of limiting evaporation in the Southwest. Possibly, we may want to let more evaporation take place as we get the system in place and have a bit of more security for our water so we can transform the environment. And that's going to be the other thing that the operation phase is going to be doing, is they're going to be working with certain groups as far as promoting certain kinds of land cover to maintain desired moisture and evaporation rates in the Southwest. It's been shown that the evapotranspiration of plants can be affected by large reservoirs in arid regions, which can themselves, that change in evaporation, change the moisture in the area and cause changes in the weather or accelerate certain changes that are already going on in the area. and change precipitation rates. So what kind of land cover? They'll be working with this NAWAPA 21 authority for distributing the water for certain agricultural forestry needs based on scientific analysis, and certain groups will be working with that. So these are the 4 phases. And again, we're going to have to be looking at these phases in relation to a couple things. One, take a look at the labor capacity that we've just outlined with preliminary analysis using the Bureau of Labor Statistics, which everybody knows is farly underrated and has a lot of fakery constantly going on. Same with machinery, manufacturing capacity. But even looking at that, you can see we're going to need to bring a lot of these engineering, machinery, everything online. We're going to have to gear up, in a sense, as though for a war, creating a new generation of workforce. What we're beginning now, we're going to set a process in motion that a preschooler right now, when they can finally graduate from high school, they're going to be moving into an area of employment and skill and opportunity, which is going to not just the construction of this project, but all of the things that we can open up. That leads us to one of the most important parts of this whole process, which is the investment analysis of this control center. As I said, in the beginning phase, they're going to be bringing in all the data as far as what's our plant capacity, what's our labor capacity, what's our current status of technology of infrastructure, current technology of manufacturing, and what's our scientific know-how, our knowledge. These are the resources they're going to have at their disposal in collaboration with certain government organizations. In driving a project like this, it requires a certain amount of foresight and forethought. And so what they're going to be looking at is, as they lay out these stages, each stage is going to have to be ready to move seamlessly, so that we put into the skill and the training mode, the mode of training, and the technology manufacturing early on, we put into that investment the future technology we're going to need. It may not be applicable right away. It may be applicable later. But we design something in so that as we get ready for another big investment into this project and in the related sectors of the economy, we've already got the skill and we've already got the capacity to move. So we don't find ourselves in a situation where we can't keep moving ahead with the economy as a whole. And that's going to mean that we're going to have a very good, accurate sense of how this process of real physical capacity grows. Our training, which in some cases for some of these professions take 3 to 5 years, is going to have to be tracked. That data is going to have to come in. We're going to have to see what's available here. Our plant capacity, which right now is strapped, is going to be basically maxed out. We're going to use all of it. That's going to have to be tracked. And we're going to have to find out how we're going to invest such that we don't drain too much of the economy, so that we maintain higher productivity of the economy as a whole than what we need at any certain point for production. So this is the rule, that the productivity, the potential of the economy, the flexibility, the capacity of the economy has to be higher than is actually needed for production. So the allocation of these resources is going to be the job of this investment management division. So as these things come in, there will be cycles of investment. So this investment cycle management division of the control center of the NAWAPA 21 authority is going to be working with government and driving the most important part of this, which is make sure that during this whole period of the generation, we always continuously increase our power and actually move the whole economy up to a higher level of operation, of infrastructural technology potential, and overall what we've been defining on this website as the energy flux density of the economy as a whole. And one of the important parts of this is going to be, again, designing in the future technologies that we need in later phases of the project, and also related phases for the economy as a whole. The space program. What are we going to do as far as industrializing the moon? What technologies can we incorporate into this project so that when we have the economy up to a power, we can start making a serious investment in space technologies? We can now draw from a generation that's been working here into that generation. So those are kinds of things which we might not see applied specifically to this project, but they'll be applicable later on. Two big areas of this: the tunnel boring industry, obviously mining on the moon, things like this. Also, the Arctic regions of the north, where right now they have a city designed for northern Russia, Umka, which is also to serve as a design for a city on the moon. So these kinds of technologies in advanced technological investment, high-end machine tool investment, we should start thinking in the early phases of this project, design that in. So this will be one of the crowning achievements of this plan is the initial phase, mapping out everything we're going to need for this plan, and moving all of these resources in a designed and allocated way such that the economy as a whole continues to grow even while all of this activity is set in motion.